All right, so area under the curve. Today we are going to be finding the area under the curve to the right and between two z-scores. So this takes a little bit of extra work compared to what you did yesterday. It takes going to that standard normal table, getting that information, and then kind of interpreting it a little bit more. So that's basically what I say right here, and now I'm explaining it in this video, okay? So let's go back to that trusty PowerPoint that we keep going to, and let's talk about a few examples. Everything you've learned. Okay. So you learned how to read the standard normal table yesterday, and what the standard normal table tells you is all of the area or the percent of the data that is to the left, or I usually think below that given standard deviation. So it tells you this shaded blue area, the area to the left. But what if we wanted to know the area on the other side, the area to the right? That's where we're headed, okay? So here's another one where they were looking up, they did the -0.2, then they got the 0.4, and they know that area to the left, okay? So this is all for area to the left, to the left. Now, to find the area to the right of z, a given z-score, you're going to still use that standard normal table to find the z-score for that value, the 1.2. So the first step is to take that 1.23, and go look it up in the table, figure out the value, and what that number will tell you that you find the 89.07% or 0.8907 of the data is here. It's to the left. The table will always tell you the information to the left. In order to find how much area is to the right, it's actually pretty simple. If we go back to the foundation of this, how this is a normally distributed set of data, all of the data is somewhere underneath the curve. 100% of it, or one whole, is under there. And this decimal, this 0.8907, is to the left. If we know what the whole is and we know this part, how do we find the other part? Subtraction, exactly. So we're going to subtract from 1 to find this blue region. If you want to find the area to the right, you just need to find the area to the left and take it away from 1. So we have 1 minus 0.8907, and that gives me 0.1093. 10.93% of the data is there to the right. Okay, hopefully area to the right makes sense. You've got all the data under here somewhere, and so you're just going to take away that piece and you'll be left over with this piece. It's a little bit of subtraction. Area between two z-scores is a little trickier, okay? So here's our process for this. To find the area between two z-scores, find the area corresponding to each z-score, and again, we're going to subtract. We're going to take away the small area from the large area. So let me see if I can explain this. What they want right here is to know how much data falls between -0.75 and 1.23. They want to know about this blue region. When we look up these numbers in the standard normal table, it will tell us all of the area below that moment. So like it would tell me all of the area here below the 1.23, and then I would also have all the area below the -0.75. So we know that the area to the left of that z-score is that 89.07%. We know the area to the left of this -0.75 is 0.2266. So this like cream chunk right here is 22.66% of the data. And then from this all the way down is 0.8907. So if you imagine having all of the area below and taking away that baby chunk, take out the creamy stuff, right? If it was all covered in blue, that would be what the first number gives me, the area left of the larger z-score. If I subtract out this portion, if I delete that portion out, does it make sense how you would be left over with this blue? If all of this was blue and I took out that little cream piece, then I would only have the area between. So that's what we do. We subtract to find the area of the region between. So we take the larger area, we subtract the smaller area, and we have in here, this blue portion is 66.41% of the data. And that is how you find the area between two z-scores.